here at the V&A Waterfront Tower Clock. Just wanted to update everyone on what's been going on here. We wanted to make sure that we had plans for this clock in case anything went wrong in the future. Gear could break, anything could happen, and without plans it would be very difficult to replicate or reproduce. Most of the time we can repair stuff, but this was just maybe in 100 years' time they want to replace something, they need plans. So we took the entire clock mechanism apart. We took it to a very specialized engineering company that have got a pressurized control room where they take very, very accurate measurements. And they've measured the entire clock. They came here and they measured the framework. And what they're going to do with that is they're going to make a computer drawing, which I'll post later on as soon as I've got the drawings done. The drawing will be 2 stages. The first stage is a program called SolidWorks, which is a version of AutoCAD, and they'll produce a 3D working model of the clock. So it'll actually work in virtual reality. The other thing that they're going to do is 2-dimensional plans. So each part will have a plan which an engineer or manufacturer can use in the future to reproduce anything that breaks. While that was being done, we decided to do a couple of other things. First one, replace these cables. They've been in here since 1883, they've never been replaced, and they were starting to get a bit old and tired. We also looked at all these pulley wheels. See the cable right here, runs across, goes down through a pulley wheel. It then goes up, and there's pulley wheels up there in the ceiling and running along. So every single pulley wheel was taken out, and they put roller bearings inside the wheels to reduce the friction as much as possible. The other thing we had a problem with was the weights. They kept running down, and they ran right through the entire building, 3 stories high. And previously they were inside wooden cages. So as soon as there was a problem where they jammed or something went wrong, we couldn't access them and work out what was going on. So I had these metal cages custom built. I'd like to say thank you to Andre Deploy for that. Brilliant metal worker. We came here to fit everything, and it fitted snugly like a glove. As you can see, he had to do a lot of fabrication and cut panels out to fit around walls and around things that are skew and what have you. So the weights now run inside there, and if at any stage they jam, we are then able to work out where they're jamming and make a plan. And as I said, they run right through the entire building. So here's the second cage. The weights will come down and run right down through there and then through the bottom floor. You can see in the middle of the weights there's this wooden panel, and that just stops the weights from knocking into one another if they're coming over one another. So the weight won't, when you're lifting it or when you're dropping it, winding it up or letting it run down, if they meet one another they won't jam up against one another. And this is the top floor, and as once again you can see he's had to bend the metal, fold it around the walls, around everything that's going on. And in theory, we should now have the clock running for a week. So we're going to monitor that, and we're going to make sure that it doesn't jam anywhere, and we've got the clock back to what it should be.